welcome to another WJEC A level physics question. This time it's question 1 from May 2009, Unit 2, question on basic waves, which is still in Unit 2 in the current specification. What we've got is a progressive wave is travelling from left to right, and we're given displacement time graphs for the same time interval for 2 points A and B in the path of the wave. B is 0.3 meters to the right of A. And the first thing we've got to do is write down the value of the amplitude of the wave. Well, remember that the amplitude is the maximum displacement of the wave, and if we look at that, we can see that the maximum displacement, reading the scale carefully, is 0.04 meters. Next, we've got to calculate the frequency of the wave. Well, if we look at either diagram, we can see, for example, on the left-hand diagram that one wave is completed in 0.2 seconds, and the time it takes to complete one wave is known as the period, given the symbol capital T. So T is 0.2 seconds. There's a very simple relationship then between frequency and period. Frequency is 1 over period, so 1 over 0.2, which is 5 Hertz. Next, we've got to show that 6 meters per second is a possible speed for the waves, explaining your reasoning carefully. Well, let's take this first peak here at 0 seconds on diagram A. Let's assume that that's the same peak over here on diagram B. So that's what we're going to start by saying. So let's write down something like, assume that the peak at 0 seconds for A is the same peak at, let's just check that time, 0.05 seconds for B. So once again, it's just basically saying that this peak here, we're assuming that it has moved to this peak there. Now, so what's happened then is that the distance travelled is 0.3 meters in a time of 0.05 seconds. So now we can use speed as distance over time. 0.3 meters in 0.05 seconds, which will give us the 6.0 meters per second that we're asked for. Next, we've got to explain what's meant by the wavelength of a wave. Now at GCSE, most people would define the wavelength of the wave as a distance between two peaks or two troughs or something along those lines. But for A level, we're a little bit more precise. What we're going to say is that the wavelength is the distance between two consecutive points that have the same phase. So for example, two peaks of the same phase or two troughs of the same phase. Or if we go back to the original diagram, well, we can't do it with these diagrams because these are time on the axis rather than distance on the axis. Next part, taking the wave speed as 6 meters per second, calculate the wavelength of the wave. Well, here we can simply rearrange the basic wave speed equation, where the wavelength lambda is the speed over the frequency. We're told to take that the speed was 6, and we calculated the frequency earlier to be 5 Hertz, and 6 over 5 is 1.2 meters. Just very quickly go back to part B. Now, I mentioned in part B that we had to show that 6 meters per second was a possible speed for the waves. But it's not the only possible speed, because it could be that this peak at 0 seconds on A is actually the peak at 2.5 seconds on B, or 4.5 seconds on B as well. And you'll find occasional exam questions that will ask you to calculate alternate speeds, and that's what we would do there, is just assume that this point has not moved to here but has moved to either here or here, and so on. So thank you very much for listening. Please remember to like and subscribe, and feel free to comment below. Goodbye.